Welcome to Part 4, Queue and Deque. This part teaches breadth-first thinking, sliding window optimization, and some of the most useful interview patterns. Queues look simple, but when combined with patterns, they become very powerful. Here is the roadmap. We begin with queue fundamentals, then understand breadth-first search. After that, we move to Deque, and finally solve sliding window problems using monotonic Deque patterns. The outcome is pattern recognition instead of guessing. What is a queue? A queue follows one rule: first in, first out. The element inserted first is removed first. Insertion happens at the back, and removal happens at the front. All core operations run in constant time. In C++, we use the queue container from the STL. It is a container adapter built on top of Deque by default. You cannot access elements randomly. Only front and back are allowed. This enforces correct queue usage. When should you think about a queue? Whenever the problem involves levels, shortest paths, or processing items in order of arrival. Queues process work in the exact order it was discovered. Breadth-first search, or BFS, explores level by level. We start from a source, push it into the queue, then repeatedly pop from the front and push its neighbors to the back. In unweighted graphs, BFS guarantees the shortest path. This is the BFS template. Push the starting node. While the queue is not empty, pop the front, process it, and push its neighbors. This template appears everywhere in trees, graphs, and grids. Level order processing is a common trick. Before processing a level, store the current queue size. Then process exactly that many elements. This guarantees one level at a time and is a favorite interview pattern. Common queue mistakes include forgetting to mark nodes as visited, which causes infinite loops, using a stack instead of a queue, which changes traversal order, and modifying the queue without controlling iteration size. Queues are powerful, but for some problems they are not enough. That is where Deque comes in. What is a Deque? Deque means double-ended queue. You can insert and remove elements from both the front and the back. All these operations are constant time, giving more flexibility than a simple queue. In C++, we use Deque from the STL. Unlike queue, Deque allows random access, but its real power comes from fast front and back operations. Deque is the backbone of many sliding window problems. When should you think about a Deque? Whenever you need maximum or minimum in a range, sliding window optimization, or removal from both ends. Deque is often the optimal solution. Sliding window maximum problem. Given an array and window size k, find the maximum element in every contiguous window. Brute force checks each window and is too slow. We need something better. The key insight is that we do not need all elements, only candidates for maximum matter. If a new element is larger, smaller elements behind it will never be useful again. Deque helps remove these useless values. This leads to a monotonic Deque. Monotonic means ordered. We maintain a decreasing Deque where the front always holds the maximum. Each element enters and leaves once, making the algorithm linear time. In the C++ solution, we store indices in the Deque. Before adding a new index, we pop smaller values from the back. We also remove indices that fall outside the window. The front always gives the current maximum. Why not use a heap? A heap gives O log k per operation, making total time On log k. A Deque gives On total time. Interviewers expect the Deque solution for sliding window maximum. Let's summarize patterns. Breadth-first search uses a queue. Level order traversal uses queue plus size trick. Sliding window maximum or minimum uses a monotonic Deque. Pattern recognition is everything. Practice plan. Solve 8 to 10 Queue and Deque problems, focusing on BFS and sliding window questions. Once this clicks, many medium problems become easy. Next playlist, hashing patterns.